Hello everyone. Today is December 18 and it's time to check out a new problem from LeetCode for our coding advent calendar. Today I've got something special for you, a holiday special episode. I will tell you about 3 ways to solve the problem, but I will implement only one. The best solution out of 3 you should implement yourself. Let's start and see. This is today's problem. Daily temperatures. Given an array of integers, temperatures represents the daily temperatures, return an array answer such that answer I is the number of days you have to wait after the ith day to get a warmer temperature. If there is no future day of which it is possible, keep answer I equal to null 0 instead. So here is our example of input data. And here is a node output. Okay, let's see how it works. Day 1, temperature is 73. I think it's Fahrenheit, right? It would be strange if it's Celsius. And nevertheless, it is 73 and the next day will be 74. That means we need to store 1 here. 74, next day will be 75, which means 1 here. 75, then the temperature goes down and the next one is 76 in 4 days, which means we need to store 4 here. 71, 2 here, which is 72 the day after tomorrow. 69, 1, 72, 1, 76 is and 73 zeros because there are no observations. So the straightforward implementation of to solve this problem is to just take 1, go to the end of go into the direction of the end of the array and try to find the value which is greater than current one and count the number of days. Then set the value here into answers and move to the second value and so on. The problem with this algorithm would be its time complexity, which would be n square, big O of n square. Because in worst case scenario, for each of these values, we need to go through the whole array. It would be a little bit less than n square, because starting from this middle of the array, it is technically less than half of array, but it would be eventually n square in big O notation. Can we do better? And in order to figure out how to do this better, we need to do some interesting observation here. So let's consider we have empty values here. Okay, let's do this. So we have first value 73 and we go next and we see 74, which is bigger than 73. That means we need to put 1 here and forget about this value because we already done with it. Next, 74. 75, which is the next one, is bigger than 74. We need to set 1 here, and we will not take it anymore. 75. The next one is 71, which is less than 75. And in this case, we will not do anything yet with this one, but instead we will go to the next value, 71. 71, the next one is 69, which is also less than 71. Again, we cannot set anything here yet. 69, the next one is 72. And from here, we can do the following. Since 72 is bigger than 69, we can immediately set 1 here, right? And then we can go back and revisit all values we had, which does not have any answer yet. So we go back to 71, which is less than 72, and we can immediately put 2 here. And we go back to 75, which is bigger than 72. And we cannot do anything with this yet, so we go further. 76. 76 is more than 72. That means we can set 1 here immediately and go back. Since for 69 it is set, for 71 it is set, 75 is less than 76, which means we can count the number of days we skipped here, or more precisely, we can just rely on indices of the input array. We can just compare index from here, index from here, and calculate value for here. We do this and continue in this manner. Can you see the data structure which can help us with this algorithm? And okay, let's check if it's better than n squared. Yes, it is. It is actually big of n, since we need to scan the algorithm, since we need to set result for each value only once, and we need to go through this array only once. And if we use data structure like stack, we can implement this as a big of n. How stack can solve our problem? It can take this part of algorithm which holds values which are bigger than the next index, the next value we consider in the algorithm, so we can revisit it later. Okay, so let's do this. Let's implement. Okay, so we created our values for our algorithm, and next we need to go through the array. let's for simplicity set it to C. So we take the current temperature from an array, right? Next we do the following: while stack count more than 0 and temperatures if the value from stack is less than current value, that means that we need to update answer for this value in an array and set it to the current date, which is more precisely the difference between current date and that date. Okay, let's do this. For you to more visibility. Okay, so we take the previous day from stack and answers of pref equal to current minus pref. Okay, so it's difference between 2 days, and we can do this since the current temperature yes, the current temperature is more than the temperature for that day from the stack. So we took this value from stack, and once we done this, we need to put the current value on stack to be able to find appropriate date later for this one, to set it to answer. Okay, let's try. Okay, yeah. Evening, sorry. What next? Answers. Okay, all 3 cases work. Let's submit it. Okay, this solution is accepted. Let's go back to our description. So, the time complexity for this algorithm is big of n. First of all, because we put each value on stack only once, and for each value we will have one solution. This inside while loop can make you feel like it's loop inside loop, and the time complexity is still big O of n square. But if you look at this, how it works closely, you will see that it's still big O of n, which is in our case 2n actually. So we need to go through array 2 times actually, backward and forward. But okay, this is a solution with help of stack. Because of this stack, we still need to have additional memory, which is big O of n as well. So the solution for this one, for the time complexity for this solution is big O of n, and the memory consumption is big O of n. But this solution, this problem can be solved more effectively from memory perspective. We can do this without stack, but still have big O of n from time consumption. Okay, if you're still with me, let's try to consider another option here without stack. So let's remove it from here, and let's refresh our example here. The idea is to go through this list of values in backward order. When we do this, we can track the hottest day in a single variable. I will mark it as h. So let's try. First, the hottest value is 73. We do not do anything since this is the first value. The next one is 76. It's hotter than 73, so we update our h here and don't do anything yet, because since this is the hottest value, we are not able to find the next day for it. Next value is 72. It is less than the hottest value. That means we need to calculate the number of days to the value which is bigger than 72. And we do it this way. We take guess that it will be the next one, since we do one step at a time, and we will check the next value, which is the current one plus x equal to 1, right? Okay. And if it's more than 72, we will just set this x to the result here, like this. And we're done with this. And we finish with this value, and we go next. See what will happen next. We take the next value, 69, which is less than the hottest value, 76. And we again create our variable, and we guess that it's 70. It's 1 the day, the number of days to the more hottest value. And we go to +1, we find 72, which is bigger than 69, and we can set this x to this and remove it. Then we go to 71. The 71 is less than the hottest value, 76, and we again create our x here, x equal to 1, and we try to touch our array to the next day. It is less than 71, which means that it is not the value we seek. And we already took this x and set it to 1, but this one also says the next value, which is greater than 69, is 1 day ahead, which is 72. So we add this value to this x and we get 2 here. And next time we try to touch this value, 71 plus 2 indices, which is 72, which is bigger than 71, so we can set this x here to 2 and remove it. Next one is 75, which is less than 76, and we repeat our procedure. 71, x plus 1, the next one, which is 75. The next value will be 71. But look, this 71 says the next value, which is hotter than 71, is 2 indices ahead, 2 days ahead, which means we immediately skip this 69 and we take this 72 here. So to this one we add these 2 and we get 3. And we try it again. 75, 3 indexes ahead. 1, 2, 3. It is 72. 72 is still less than 75, but it says that the next hottest value is 1 day ahead. We take this 1, add it to this 3 and get 4. Next time we take this 75 and try values for days ahead, which is 76, which is bigger than 75, and we take this 4 and put it here. And the next iterations will go with x equal to 1, 1 and 1. That's it. Without any stacks, which leads us to constant memory consumption, it is still big O of n, so it is the best solution possible, probably. And I will not implement it. I know it works, I checked it, but I offer you to try. And let me know in comments how successful your tries are. Let me know how much points do you get from this LeetCode submit button, how fast your solution is, how much memory does it consume. That's it. We just discussed the algorithm to solve the problem using a constant memory. Have you noticed how quickly we found the most time-consuming solution? Then we implemented another one in linear time, but it also requires additional memory. And finally, we discussed the best solution. Every time you implement something, you should try to estimate the time and memory consumption and ask yourself, can we do better? That's what we do here every day, becoming a better software engineers. See you tomorrow.